Greetings. This is the first of a three-part series of conversations on blockchain technology. Our guest is Dr. Paritosh Basu, senior academician and former industry leader, now engaged in research and consulting. Blockchain technology may be viewed as a part of a bouquet of technologies that are driving the fourth industrial revolution. The other path-breaking technologies driving the fourth industrial revolution are cloud computing, Internet of Things, industrial Internet of Things, artificial intelligence, high-speed data networks, automation, robotics, additive manufacturing, data capturing tools, new materials, RFID, widespread applications of digital technologies working together with vastly improved capabilities in data analytics and data management. Blockchain is a decentralized, distributed ledger technology that securely records transactions across multiple computers, making data immutable and transparent. Each transaction is grouped into a block linked to the previous one using cryptographic hashing, forming a chain of blocks. This eliminates the need for intermediaries, enhances security, and ensures trust in digital transactions. Blockchain applications extend to finance, manufacturing, supply chain, healthcare, voting systems, and beyond, transforming industries by enabling transparent and tamper-proof record keeping. Our guest, Dr. Paritosh Basu, is a Senior Director of Strategility Consulting Private Limited. Dr. Basu is an adjunct faculty at Indian Institute of Management, Kozhikode. Dr. Basu has 34 years in industry, serving as Group Controller and CFO of two large MNCs in India. He is a Fellow of All India Management Association. Dr. Basu is recognized by Blockchain Foundation of India as among the top 50 blockchain influencers in the country. Hello, Dr. Paritosh Basu, and thank you for joining us on this session on blockchain technology.
Thank you, Dr. Bhadra. Thank you for having me in your blockchain technology series session.
Right. My first question to you, Dr. Basu, is who are the major members of the digital technologies table and how is blockchain technology positioned amongst them?
That's a very interesting question to start with, Dr. Bhadra. Digital technology or any other technology for that matter, computing technology or mechanical, whatever, are generally looked at from the perspective of its impact on the business. When digital technology started becoming very evident from around the late 1990s or even mid 1980s, when it was not even hard, we did not have any such analysis. We started having the analysis from 2016 in terms of digital technologies, and you can see the map here. In terms of business impact, generally a technology is considered as a low business impact, medium business impact, and high business impact. Certain technologies which transform the way of doing business, which comes in the form of a revolutionary change in the way of doing business, that is called transformational technology, or impacts of which are changing the way of doing business. Blockchain technology started being traced by historians of technology sometime in late 1980s, early 1990s, when people started thinking of creating independent transactional platform which are supposed to be run by the platform itself. So originally, we didn't see any implications and applications of blockchain technology until Satoshi Nakamoto declared the first ever application of blockchain technology in 2008 and 9 early, when blockchain technology was used for transactional purposes of a cryptocurrency called Bitcoin. After that, through the process of evolution, blockchain technology came out from the blocks of or realms of cryptocurrency and started being used for transactional recording purposes. And in 2016, it got the first recognition as a high performing technology. I have done a lot of research on this technology, and my research tells me to conclude that blockchain technology has traversed the path from high impacting technology to transformational technology. And if we can draw a quadrant here and name this quadrant as foundational, then blockchain technology is now a foundational technology. And my research is supported by a paper of Harvard Business School where they say that blockchain can change the economic and societal foundation of any country under the sun. This particular report was submitted in the Davos Economic Summit sometime in 2018. We'll look at this as we go forward in our discussion. Coming to the stable of technologies question, Dr. Badra, essentially the world has so far seen 8 digital technologies, starting with blockchain. The second major technology is artificial intelligence. The third major technology is drone. Then comes the Internet of Things. Internet of Things, of course, has got a lot of variation. Artificial intelligent Internet of Things, industrial Internet of Things, robotic Internet of Things, etc., etc. Then comes, of course, the robot. And robot is, of course, not a digital technology. Robots is essentially a mechatronic which runs with the help of computer technology from the perspective of control purposes. But when a robot is made artificially intelligent, then of course we call it a technology which is within this treble of digital technology. Then comes the 3D printing, virtual reality, then comes augmented reality, and finally artificial intelligence. The beauty of artificial intelligence as a technology is that this particular technology can be integrated for augmenting the purpose and objectives and goal setting of any technology, and also bringing in lots and lots of innovation within that technology. Like an artificial intelligence layer can be added to blockchain layer. We'll talk about it later in our subsequent sessions. But at the moment, let us put it this way. You can see some blue stars and black stars. The blue stars indicate that blockchain as a technology can be integrated with any technology called drone, Internet of Things, robots, artificial intelligence, and now augmented reality and virtual reality, since these two runs with the artificial intelligence platform together. And hologram comes into it, which is called metaverse ultimately. That is also now can be handled with blockchain technology. So blockchain technology is essentially not in the nature of artificial intelligence. It's a transactional technology, whereas artificial intelligence is a technology which adds the power of doing work and bringing in innovations and bringing a lot of analytics and subsequent findings and changing the technology in terms of customer behavior understanding, and many we can discuss it later sometime. So essentially what I'm trying to say is that in the stable of digital technology, there are 8 technologies, as you can see here, out of which blockchain is a technology which can be integrated with almost all the technologies. And artificial intelligence, of course, can be added to any other technologies in terms of infusion. That is what it is. After that, there are very many variations have come in. In fact, blockchain presently is now in its 4th version. Let's proceed further.
Sure. Thank you very much, Dr. Basu. That was very enlightening. My next question to you is what are the core fundamental features of blockchain as a digital technology?
Okay. Now let us come to this point to first demystify one issue. As common people in general has not seen application of blockchain technology and much not, of course, on their smartphone at the front end. That's why people synonymously use the two words blockchain technology and cryptocurrency. They think cryptocurrency is blockchain technology and blockchain technology is cryptocurrency. Essentially, these are not. Cryptocurrency is an application of blockchain technology, and cryptocurrency transactional platform is blockchain technology, and trading of currencies are done in this platform in different ways. So please let us not misconstrue that blockchain is equal to cryptocurrency and cryptocurrency is equal to blockchain. Having said that, let me share with you the nature of this technology, Dr. Bhadra. Essentially, all the digital technologies can be categorized into three major groups. One is the intelligent group, that is the AI powered group. Next is the digital group, which is augmented reality, digital twin, etc., etc. And finally is the mesh technology, where the computer technology and digital technology helps us to get into a network. Originally in 1970s, when you used to see the connection of computers, there used to be this kind of a connectivity where there used to be a central server, and each computer which is connected to a central server used to call as a node or a connecting computer or connected computer. So that time it was a centralized network with one center operating and connecting with each other. Each peripheral node has not had no connectivity with each other. There was no such connectivity. It was not present. Then came the hub and spoke network, which is called the decentralized network, where at a certain level, certain computers are connected to a particular hub, and those hubs are connected to a central network. That is the way it used to operate earlier. Okay. Now, when we have seen in the early stage of banking in India, we could only do banking with our own branch. Then the branch could do with the state, and state could do with the center. And the states, this particular hub is not connected to this particular hub. That is the demerit or the obstacle or the hindrance of a decentralized network, which is not connected through a distributed ledger technology or blockchain technology. A blockchain distributed network is looking like this. Here, I can't draw it that way like we drew it the other two cases. Here, each node is connected with each node. There is a direct connectivity. This particular computer can speak to this particular computer. This computer can speak to this computer. Each node can speak to each node because it's a part of a centralized system. That's why it is called a peer-to-peer network. Here the peer could be a business, the next peer could be a consumer, the first peer could be a consumer, next peer could be a consumer, and so and so. The first peer could be a government, and next peer could be a citizen or a company. So this is called a peer-to-peer network, which is the distributed network. Now, blockchain technology has got the second name, which is its nickname, which is called DLT, Distributed Ledger Technology, or a peer-to-peer technology. Each anonymous ledger, that is the computing node, is protecting the identities of users. In any digital technology usage in today's world, particularly in Web2 platforms, every single person is either known by his phone number or by his mail ID or by a unique login code, which is easily connectable to his phone number or his Aadhaar card number or PAN card number or any other identity card. In a blockchain technology, that doesn't happen because it operates with a dual key mechanism. One is a private key and another is a public key. When somebody enters into a blockchain platform, the public key is used for the transactional purpose, but entering into the blockchain platform, somebody uses a private key. When a person announces a transaction or intent of doing a transaction, this transactional announcement is coded by a public key, so people know him not by name, phone number, mail ID, or any other identity. People know that particular person issuing the intent of transaction or accepting a transaction by a public key, which is a 23 to 30, 35 letter number, continuous one kind of phrase. It is cryptographically enabled distributed data storage management system that whatever transaction is done in a blockchain technology, each transaction is encrypted with the encryption technology algorithm. Now, there are two types of encryption technology algorithm. One is a static and one is a dynamic. In the advanced version of blockchain technology these days, this cryptographic algorithm or encryption algorithm is dynamically changed every 10 minutes. That makes the system more secure. In this distributed storage management system, in the earlier version of blockchain technology, there used to be each blockchain transactional platform used to be its own storage system. That means each particular node used to have the transactional data of all other nodes. That means whenever a transaction is announced or accepted and completed, these nodes, suppose this node is participating and this node is accepting the transaction, and between these two nodes, the transaction is being done. Since this node and this node is connected with all other nodes, the transaction records used to be with all nodes. Therefore, hacking used to be very difficult, because even if you hack 1, 2, 3, 4 computer, the fifth computer is still having the data. And here 5 is just a metaphorical show. There could be 500 or 5,000 also in this. In the present day blockchain technology, this transactional node having the data of all transactions of all the nodes has been done away with. As of now, the transactional node have their own data. The blockchain's entire transactional data and documents are kept in a central blockchain cloud. That particular cloud is also completely encrypted. And each particular network gets from the blockchain platform system its own data in the form of a integrated transfer from the centralized operating system. So all transaction pertaining to this particular node, if it is node number 1, and suppose this node number 2 is node number 3 is this one, 1 and 3 is doing a transaction, the data of 1 and 3 transactional data will be passed on to them, and the central data will be available in the central storage system. That is the 4th generation version of blockchain technology. And day by day, things are changing, and the peer-to-peer network is continuing to remain, because if this particular node wants to see the transaction done between 1 and 3, they are allowed to see, provided these transactions are not in the nature of confidential transaction in a commercial platform. In a cryptocurrency platform, the old system continues, and each transaction can be seen by a group of people called miners. We'll discuss this in greater detail in some other time. Blockchain technologies, each transaction is called a block, and it is cryptographed. And when a block is completed, it is given a number which is called hashtag. This is the transactional data, and this is a pointer of the transactional data. This pointer is the tag comes to this data, and when it gets attached to the next block, it gets attached to it. Suppose the transaction started here. This is the first transaction. This is the second transaction. And if you follow the route, every route will have its previous hashtag, and this will be having its previous hashtag. And that way, every transaction is a chain of blocks. This chain started here. This is the zero date first transaction. This chain started here and it continued here. Each transaction is in a chain of block. The technical word attached to maintain this chain is called Merkle root, which is a pure technological issue, and that Merkle root maintenance is done by that hashtag, which is a computer generated tag attached to each transaction. It's a highly technical subject. I'm not getting into that. What I'm trying to take away from this slide is that blockchain technology, despite having a cloud storage system which is encrypted, even still maintaining the peer-to-peer network capability in terms of its features, it is encrypted and there is dynamic encryption available. It is completely immutable. One particular transaction cannot be immuted or erased, because if a transaction has to be corrected, it has to be corrected by another transaction. That means somebody consented to an agreement, and if that consent is to be withdrawn, another transaction has to be given. Blockchain looks like this kind of a stack. Suppose these are the application: riding share, logistics, asset management. Then there comes an application layer, which is an algorithm, the technological mechanism, and a smart contract. Then comes the incentive layer, that is the issuance and the allocation layer. That is, present cryptocurrency blockchain has an application of this layer, because the miners get their mining fee in the form of fractional cryptocurrency. But this incentive layer is generally not there in private application. Then there is a consensus layer where a transaction is approved. And in this consensus layer, you have proof of work. Then you have proof of stake. Then you have decentralized proof of stake. And then you have ZKP, zero knowledge proof. So these are various consensus layer. A transaction cannot move to the next transaction, and the previous transaction cannot get deposited to the chain of blocks of transactions without the consensus layer is completed and encryption is done. The network layer is the P2P network I was explaining to you, the data forwarding layer. Here, of course, the data includes the documentation and the data verification layer. The data verification layer has now come into the domain of ZKP. Sometimes data verification is not required to be done. ZKP layer does it automatically through an automated process of encryption and automated process of approval. I'm not getting into the nitty-gritty of the technology. Then you have the data blocks, that is the Merkle block and tree, timestamp, hash function. This hash function, more the hash function is versatile and scalable, more scalable is the technology. Then you have, of course, the devices, the vehicles, and the assets. So this is essentially the blockchain stack, which is highly technical. From the perspective of a first-time learner of blockchain technology, this may not be needed to also remembered, because this is at the core of the software programming. One must know is the layer, application layer, incentive layer, consensus layer, network layer, and the data layer. Then you can ask, anybody can ask, if I'm coming for the first time and trying to join this particular blockchain technology system, Suppose there is a import-export blockchain platform issued by IBM, and I want to join as an importer and exporter for the first time. How do I get into this system? What is not shown is the KYC layer. That is, KYC layer is generally added, is an added layer above the blockchain layer, which is not a part of blockchain technology. It can be made, new technology has come where it can be made. Know your customer layer, where a blockchain technology administrator completes the antecedent verification and document verification, etc., for making him a party to this technology platform. Once the administrator makes him a party to this through the KYC completion process, the administrator has no authority to stop him unless any unethical work is done. Now, unethical work is also not possible to be done because of smart contract coming into it. Smart contract is such an interesting governor of the blockchain technology. This is the driver, this is the brain and head of the entire system. Every single thing is done in this entire system. This is the driver. It is the compliance manager. It also takes into consideration that if anything wrong is done, it gives you a pop-up that you can't do this transaction, you are blocked here. The smart contract is essentially a library. Suppose I'm doing an export-import transaction, and generally 16 to 17 parties are involved in an export-import transaction. Buyer, seller, banker, approver, then the shipper, the shipping line, the port master, so on and so forth. And each one is a party to this blockchain technology. And there are, suppose there are exporters from German, Japan, and say US. So the smart contract takes into consideration the legal requirements of all the countries. Unless the legal requirements of the all countries are embedded in the smart contract system. Suppose somebody is trying to participate in this system from Congo, and the Congo's rules and regulations are not there in the smart contract, then he will not be allowed to participate in this. Essentially, I'm trying to say that every single transaction of blockchain technology is conducted in compliance with the law of the participating parties country and the connected parties country, etc. Suppose the blockchain technology is within their country, then of course every Indian laws are only applicable. Now, can we go to the next question, Dr. Badra?
Sure. Thank you very much, Dr. Basu, for explaining the functioning of blockchain. My next question is, how are transactions conducted and recorded in a blockchain platform?
Thank you. Now, let me give you a very interesting point here, that blockchain technology establishes a single version of truth. Because what you trust may not be what is true, and what is true may not be what you trust. So blockchain technology gives us a very interesting route map or a framework. If you comply with that framework, or if the questions to those frameworks, each step is answered either is in yes or no, you can decide whether your organization needs to have a blockchain technology or you need to participate in a blockchain technology. Let me give you a quick framework. Do you need a database? If the answer is no, you don't need a blockchain technology, because blockchain technology is essentially a database system. One of its features, as I was telling you, DDSM. Does it require shared or write access? That means any participant will be able to write something. It's a transactional platform, so everybody should be able to initiate a transaction or approve a transaction. So if you don't need it, then you don't need blockchain transaction. Are participants known and trusted? If everybody is a trusted party, then you don't need a blockchain technology. Don't spend your money on blockchain. Are trusted third parties needed, wanted, or essential? If your transaction is working on trusted parties, that is between a banker and a customer, then you don't need a blockchain technology. Are control functions needed and or essential? If the control function are needed, then of course you need a blockchain technology. Now, if the control function is such where is consensus determined. Now the consensus can be determined either within the firm or between two firms or between a public and a firm. If it is a public and a firm, then it's a public blockchain. If it is a public and a private company, then it's a hybrid blockchain. That means the two private companies who are the initiators of the blockchain platform. Suppose 15 Banks of India has started soon starting a trade finance platform. Then the private party and a public party can be a participant in it. It's a hybrid platform. And within the organization, there is no other party other than the company is having an application. It's a completely private blockchain platform like HPC or Konkan Railways. They are trying to have all their documentations and the design, all the design documents of Konkan Railways are maintained in a blockchain platform. Not all engineers will be having access to that. So access is controlled. And that is how the blockchain technology functions. That means the takeaway from this particular slide is blockchain technology you need where the database is needed. Everybody should have a right of access and right of writing a transaction. Everybody should be not trusted. There should not be any need for trusting anybody because blockchain establishes the trust. There is a trusted third party that is also not needed. It can be a not trusted third party. The control functions, these are needed control between firm, between public and a firm, and between the firm within the firm itself. That determines the nature of the blockchain, which is a public blockchain or a private blockchain or a hybrid blockchain. Now, this is the oldest form of blockchain technology transaction conducting, which is the Bitcoin, which started with, then came Ethereum and subsequently stable coins, Doge coins, all kinds of coins came. Now here, suppose I today for the first time I want to buy. So I've done my KYC and I want to announce a transaction. I want to buy 2 Bitcoins. Now here is the network of people who are Bitcoin holders. They will see this transaction will be announced to everybody, and they will see, and this person, suppose this person is B, he says, yes, I'm ready to sell this Bitcoin. Then the direct contract will not be between them because a group of people who are sitting here, they are called the consensus generating people. These people will mine the database of this particular person who has expressed that I want to sell to A this particular Bitcoin, 2 Bitcoins. Now these guys will approve that, hey, B holds a Bitcoin which is authorized Bitcoin, and in his ledger this coin is available, so he is authorized to sell. Then only B will be able to sell to A and the transaction can be proceeded with. Once earlier there used to be a large number of miners used to approve one particular contract. Now the number of miners have been reduced because of 2 reasons. It's a huge electricity guzzler, and each miner gets a fractional value of Bitcoin for approving each transaction. So transaction is then approved and deposited, and this approved transaction now get a hashtag and it is deposited. Now this is now, suppose now we are in an environment where suppose a bank is issuing a bond, and it's an end-to-end bond subscription to interest payment to bond repayment transactional platform. Here there is there are only 2 parties. There is this particular group of miners is absent here because somebody wants to do a transaction and somebody approves the transaction. So here there is no mining need. Here the need of initiator of a transaction and approver of a transaction. So a transaction is requested, the transaction is reviewed, and when the request of the transaction is done, it is done in line with the smart contract, because anything and everything has to be done in a blockchain environment, has to be in compliance with the smart contract. Then the intended party, suppose press machine, metal pressing machine, some of the parties who are participating here uh, produces metal pressing machine, and this particular in transaction is for a metal pressing machine. So the concerned parties will respond to this, and each response will be verified. So this transaction will be verified, responses will be verified. Each transaction will go to this block, the verification will go to this block, and this block, each of the transaction initiation and approval that intended to quote for the transaction, then submitting the quotation, then review of the quotation, then approval of the quotation, then entering into contract, each of those are a transaction. That cannot be explained in a two-dimensional diagram. So that's why I'm giving these arrows. And then each transaction is becomes a block, and it gets deposited, and in the process of depositing it is encrypted.
So, at what stage are we in at present, and what is the importance to business and government?
Okay, fine. So quickly, I will mention to you about a research finding of Capgemini. It did this work in 2018, and there are 447 number of respondents, and that particular research had two findings. The finding number one was that between 2011 to 2018, it was the awareness time of blockchain. 2017 to 2020, it was the experimentation time. PwC, IBM, lots of digital tech giants did those experimentation. And 2019 to 2025 is the digital transformation of business time with the help of blockchain technology. Now, the respondents gave very interesting answers. 89% of the respondents says that blockchain technology will bring in cost savings to them. 81% of the respondents say that traceability is possible right from the raw material coming into the factory till the finished product is consumed by the ultimate consumer. The blockchain will be able to trace the transaction. Like you are sitting in America, if you are enjoying a Indian bottle of wine, then even which farmer produced the grapes, you will be able to do that. And that is possible, and IBM has proved it through some other technology. Then blockchain gives the extreme transparency. That is the beauty of this, which you saw from that framework diagram, which I showed you, that every single transaction is visible and it is in compliance with the law. Then 57% says that it can increase their revenue because of the cost saving to be passed on through price, traceability, and transparency of the transaction. 50% of the people said that it can reduce their risk. 44% says that it can create new business. Definitely. And finally, 38% says that it's customer centric. So as long as these 7 benefits in this kind of percentage numbers of respondents accepting the truth that blockchain technology can do all this, believe me, Dr. Bhadra, this is approving the commercial part of the blockchain technology. In some of the sessions, we can discuss about how blockchain technology can be used by government for doing wonders, including environment management. So, Dr. Bhadra, you can see from these findings of Capgemini is that blockchain technology will definitely be a very good friend of business guys in terms of cost savings, traceability of products, transparency, revenue generation, risk reduction, creating new business opportunities, which is essentially the end of digital transformation of business and customer centricity. If this is the finding in 2018, when the technology was not that advanced, after 7 years today, when the technology has advanced substantially, I'm sure these benefits will be further sharpened and multiplied. And that is precisely the reason. Let me tell you that there are a very large number of applications are have been developed. These are not 19 applications as such. These are 19 groups of applications which are there in the finance part, finance and industry part of it, trade and commerce. There are a lot of applications. There are lots of application in the government block, and if we find someday, we can sit down and say, and then only I'll be able to explain to you why it can be considered as a foundational technology, like the Great Barrier Reef of Australia, where a lot of marine resources are getting wasted. Blockchain technology is being applied for controlling the temperature of Great Barrier Reef. There are plenty of other applications protecting the musicians' rights, the protecting others' rights, the cloud storage, cyber security, human resource protection, education, donation and charity, tokenization of physical assets for fragmentation of ownership. There are very many applications of blockchain technology. This is my last slide, where I would like to share with you very interesting data, which is of Deloitte. It did conduct consecutively from 2018 to 2019 to 20 certain survey about blockchain technology, and the end was at 1053 in 2018. It went up to 1488 in 2020. 55% of the respondents said that blockchain is a critical strategic priority of them. 27% of the respondents said that blockchain may not be critical priority, but it's important. So if we add 55% with 27%, we get roughly. So Dr. Madhur, what you can see here, that over the period from 2018 to 2020, things have improved. The top 5 agenda points have increased from 43 to 55. Since it has increased, the other thing has reduced, but it has only reduced by 3% here. The 12 percentage point has increased. So essentially 55 plus 27, 82% are saying that it is important or top of the agenda, and 14%, if you add it, is 96% of the organization feels. So if 96% of the organization, which are 1,488 organizations throughout the world is saying that blockchain technology is either important or a top priority or relevant for them, I think blockchain technology is going to say it can be a slow starter, but definitely it is going to do a transformational change going forward. It will be a foundational change oriented digital technology. Coming to scalability issue, which was earlier was a question. Now 88% people are saying that yes, blockchain is scalable, and blockchain can increase business cases. For about 86% people are saying that there are compelling business cases for 86% of the organization. 85% of the organization says that they have a plan to replace their existing transactional platform from the legacy system to blockchain-oriented system, which has increased from again 77 to 85%. And 83% of the people, which has increased from 68% to 83%, are saying that they will be having competitive advantage if they adopt blockchain, because their competitors have adopted blockchain technology. And finally, that blockchain technology is a hype or not. 54% are saying it's a kind of hype, but definitely it will be taking a slow but steady progress. So if we want to conclude, blockchain technology is something which is here to stay. It may be a slow starter, but I'm sure it will be having lots and lots of application, including government sector. Thank you.
Thank you very much, Dr. Basu. This was a very enlightening session, and I'm sure our viewers will greatly benefit from this introductory session. I look forward to having a few more sessions on blockchain to explore this very, very interesting technology. Thank you once again, Dr. Basu.